Hello friends, so here in this video we will solve the problem on trigonometry. So tan A is given as 1 by 3 and tan B is given as 1 by 4, where A lies between 0 to pi by 2, that is the first quadrant, and B lies between pi to 3 pi by 2, that is the third quadrant, and we have to find out the value of sine A plus B. Now to get the value of sine A plus B, here we can see it is allied angle, and we can apply the property of allied angles, that is sine A plus B is sine A cos B plus cos A sine B. So it means we get the value of sine A, cos B, cos A and sine B. Then by substituting these values in the formula, we can get the value of sine A plus B. And here we have been given the value of tan A and tan B. So what we'll do is, from the value of tan A and tan B, we will find out the value of sine and cos, and then by substituting all the values in sine A plus B, we can get the value. So let's start. So here tan A is 1 by 3 and A lies in the first quadrant, that is between 0 to pi by 2. Now here we will use the property of trigonometry, that is 1 plus tan square theta is equal to sec square theta, or 1 plus tan square A is equal to sec square A. So therefore I can say that sec square A is equal to 1 plus tan square A, where tan A is 1 by 3, so we will get 1 by 3 square, which is 1 plus 1 by 9, and which is equal to 9 plus 1 upon 9, that is 10 by 9. So here we got the value of sec square A. But let's find out the value of sec A, because from sec A we are gonna find out the value of cos A. So if I want sec A, then I have to take square root on both sides. So the square root of sec square A is sec A, whereas the square root of 10 upon 9 is plus or minus root 10 upon 3. So it means we are getting two values of sec A. Now the question is which value we should accept. So it depends on the angle where it lies. So here A lies in the first quadrant. So in the first quadrant we know that all trigonometric functions are positive, and hence we will accept the positive value of sec A. So here I will write, since A lies in first quadrant, sec of A is positive. So therefore sec of A is equal to positive root of 10 upon 3. Now from the value of sec of A, I will find out the value of cos of A. So therefore cos of A is equal to 1 upon sec of A, and that is 1 upon root of 10 by 3, or we can say that therefore cos of A is equal to 3 by root of 10. So here we got the value of cos A. Now from the value of cos A and the value of tan A, we can find out the value of sine A. How? So we know the property that tan of A is equal to sine of A upon cos of A. So here I will write it down. So therefore tan of A is equal to sine of A upon cos of A. So as I want sine of A, here I will say therefore sine of A is equal to tan of A into cos of A. Now what is value of tan of A? So tan of A is given as 1 by 3 and cos of A we got 3 by root 10. So here I will write 1 by 3 into 3 by root of 10. So 3 and 3 is cancelled, and therefore we will get value of sine of A as 1 upon root 10. So we got the value of sine of A from cos of A and tan of A. So after that, from tan of B, we will find out the value of sec of B. From sec of B, we will find cos of B, and cos of B. From cos of B, we will find out the value of sine of B. So let's start. So for tan of B, I'll again use the same formula. So therefore, now I'll say sec square B is equal to 1 plus tan square B. So which is equal to 1 plus, now the value of tan B is 1 by 4, so it's 1 by 4 the whole square, which comes out to be 1 upon 16. And if we'll take the LCM, then we will get 16 plus 1 upon 16, that is 17 upon 16 as the value of sec square B. But we want the value of sec of B. So by taking square root on both sides, we will get plus or minus root of 17 by 4 as the value of sec of B. So here we are getting two values of sec of B. Now again the question arises, which value we should accept. So it depends on the angle B and the location, or I'll say where that angle B lies. So here this angle B lies between pi to 3 pi by 2, it means it lies in the third quadrant. So in third quadrant we know that tan and cot are positive. So it means sec is negative in the third quadrant. So here I'll say since B lies in third quadrant, the sec of B is negative, and therefore we will accept the negative value of sec of B. So sec of B is equal to square root of 17 by 4, but it's negative. Now from this negative value of sec of B, we will find out the value of cos of B. So therefore cos of B is equal to 1 upon sec of B, which is equal to 1 upon negative root of 17 by 4, and therefore we can say that cos of B is equal to minus 4 by root of 17. So now we got the value of cos of B. Now from this value of cos of B, we will find out the value of sine of B. So we have tan of B with us, we have cos of B with us. Now let's find out sine of B. So tan of B is equal to sine of B upon cos of B, where the sine of B is equal to tan of B into cos of B. Now the value of tan of B is given as 1 by 4, and the value for cos of B that we got is minus 4 by root of 17. So this 4 and 4 will be cancelled, and we will get sine of B as negative 1 by root of 17. So here we got four values, that is sine A, sine B, cos A, cos B. Now let's find out the value of given question. So here we have to find out sine of A plus B. So here I will say, so therefore sine of A plus B is equal to sine of A into cos of B plus cos of A into sine of B. So now let's substitute the values. So first of all we'll need sine of A. So we got value of sine of A as 1 by root 10 and cos of B as minus 4 by root 17. So here I will say 1 by root of 10 into minus 4 by root of 17. Next, plus we want value of cos A and sine B. So we got cos A as 3 by root 10. So 3 upon root 10 and sin of B is minus 1 upon root 17. So by multiplying these two terms and these two terms, we will get minus of 4 upon root of 170, and here we will get minus of 3 upon root of 170, which is equal to minus of 7 upon square root of 170. So we got the value of sin of A plus B as minus 7 upon root of 170. Thank you.